Hello everyone, welcome to Dev Days of Summers, and today I speak about how to simplify cloud with Delphi. Well, in this presentation, we will see monolithic microservices, what is a function as a service, architecture, Google Cloud Platform or XP, Docker. Let's go. Let's see everything in the practice. And I left my contacts in the case you have questions. And in the end, we will have our Q&A. Okay, good. Well, before starting this presentation, let me introduce myself. My name is Daniel Fernandez. I'm a senior developer at Aquasoft. More than 9 years old experience with DeFi, graduate in the information technology management. I'm a postgraduate in software engineer. I'm a creator of Dinosaurs on Instagram. This is a community, Delphi community on Instagram. I'm a creator of the component Dinosaurs libraries for Delphi available on my GitHub. Is an open source component. And I speaker at DelphiCon 2023 and the Embarcadero Conference 2022, 2023, and in this year. Well, let's start. Monoliths. What is the monoliths? A monolith is a software architecture in which all components and functionalities are integrated into a single application. Look at this picture. We have a monolithic instance, and all the components and functionalities are integrated in a single application here, like payments, orders, sales, and in the monoliths, we have a single communicate with database, and we have a simple user's interface communicate directly with this instance of monoliths. And advantages of monoliths. You need to simplify in architecture because all the features are integrated into a single location, like this image. It is good for creation MVPs because it is easy and quick to develop. Because the same reason, team cohesion among developers. Because in the monolithic architecture, we use only one language, which makes it easier to create a development team. Simple to deploy to production. If you update a feature, the entry application will be ready to deploy to production. And is to debug because all the feature is in one place. Here, I recommend monolithic first is a post of the Martin Fowler. If you're interested about the monolithics, I recommend you read after this presentation. And disadvantages of monolithics. Everything is in one place. When everything is in one place, generate a high dependence. When I generate high dependence, I generate low scalability. And other disadvantages of monolithics is it's a take time for a new developer to get accustomed, and a problem in one part of the software affects it as a whole, a database, and a single technology. A single technology is a problem because if you have a problem that another technology can solve in a simpler way, if you use just one technology, you are stuck with it. Other approach is a microservice. What is a microservice? Microservices are an architectural approach that designs software as small, independent services which perform a specific functionality. Each service operates as an autonomous entity and communicates with other Strokes APIs, creating a modular and scalable application. Look here. In monolithic architecture, we have many functionalities into only one instance. Have only one database, and only one user's interface. But in microservice, we have many instances, and each instance is a microservice. Each microservice have your own responsibility, and which microservice have only one database. These microservices have just sales responsibility, and this database have just information about sales. In microservice, we can have many users interface, like a mobile, like a desktop, like a web, and which microservice is an API. Microservices communicate with each other. Well, when to use the microservice? Large and complex applications need to be highly scalable and adaptable. Applications that have many domains and subdomains need for continuous integrations and implementations. Here we have an impressive microservice architecture and have a client, API gateway, microservices, and Dockers, containers, and orchestration. Here we have a sentence about the microservice. Don't use a bazooka to kill an ant, because if your application is not too large, you don't need this approach. And features of microservice. Divide tasks independently. A service should implement only one function. Agile swap service. Communication is done through well-modeled HTTP APIs, built through small responsibilities, automated deployments, different language can be used. Here is what we are going to build. We use the Angular client, API gateway built with Delphi, microservices in Delphi. We use Docker for containers, and we use Google orchestration for containers. And we use NoSQL database with Google Firebase. And what are the advantages of use microservices? Scalability is efficient. You can scale your software better with ease of maintenance. This is a somewhat divergent point as well. That this ease of maintenance refers to have a smaller piece of code to analyze. The technology is diverse, it is resilient and fault tolerant. So if you manage your coupling properly, one microservice won't stop the other, and with parallel development, you can break down your microservice into several microservices. Give you the possibility to granularize your software well and the ease of horizontal scalability, which is what it means to granularize the software. And its advantages. The complexity arises from the size of the architecture, refactoring test, where you have an input and output and you have small business rules in the microservice. But finding where the problem might be can be a bit more time consuming. They increase the cost of fixed bugs. They increase the cost in the terms of the time it takes the developer to find where the problem occurs. Can be either latency communicate is always done via HTTP. In this case, Google offers VPC Virtual Private Cloud, which is a local network within the cloud. And this local network allows you to connect your serverless functions, which significantly reduce latency, but we are still talking about HTTP communication. So that's the advantages. Data management over the long terms, You will have multiple database and at some point this can become complex to manage. And not all applications are large enough to be divided into a microservice, which is something to consider when choosing this approach. And the best practice for microservicing. Each service in a microservice architecture has its own database. Preferably use asynchronous communication. Communications between microservices should be done through REST API exposure. We should avoid coupling. The API gateway should centralize authentication, routing, and load balancing, reach limitation, and app logging. Everything should happen within it. It is like a swagger. Avoid cascading failures. By avoiding microservice coupling and being mindful of dependency between microservices, you can avoid cascading failures so one microservice won't stop another by failing at some point. And how to migrate from a monolith to microservice. First, you extract a functionality from your monolith, move it to a microservice and test it. Avoid refactoring everything at once. You should first think about decoupling the service from a monolith. When starting to migrate your monoliths to microservices, you should always first consider the business rules and not necessarily the technology. Migrate service gradually, and you can use a pattern called shared database, where you migrate several functionalities from the monoliths to microservices and reuse the database. They gradually decouple the database. So sharing the database between microservices is a temporary measure. Microservices require a lot of automation, so you should think a lot about DevOps. At this stage for builds, create automation and pipelines. And what is function as a services? It's impossible to work with clouds and microservices without talking about FAAS or functions as a services. Functions as a service is a backend services, a server that isn't a server. It is a service that will be waiting to call it. And when a HTTP request comes to it, it will active trigger the microservice and return a response, and that's shutdown. And what are the advantages of using it? You have improved deployment speed because you don't need to worry about the infrastructure. It is all managed by the cloud provider. Scalability is built in, so you don't need to worry about traffic with contingents. This will be managed by the cloud, cost efficient because you don't pay for a server, you don't have a service run on time or a virtual machine. You only pay for the time your service is executed. You send a request, it executes your microservices, gives you return and shut down. From that moment on, there is no more cost. It's similar to a tax meter. And what are challenges of functions as a services? You have less control over the system because you don't have directly access to the infrastructure. So understanding it can be somewhat complex, and it is more complex to test because when testing you will have to use the local environment and you will have to try to reproduce as closely as possible that cloud ever wanted on your test machine. And the concept of serverless. The concept of serverless is exactly the same as functions as a services. Serverless functions are implemented in containers that are start on demand. So functions as a service is a serverless. And here is a representation of the architectures. I wrote functions as service and serverless here just to compare. There is the same representation of cloud trigger functions. This is what we are going to build, which I have already explained. And here is how GCP works with functions as services. We will have the cloud build, which will generate the artifacts that will be our container orchestration, which will store our Docker. And the cloud run is your functions as services, which will trigger when calling the microservices. And what is Google Cloud? Google Cloud is nothing more than physical and virtual resources spread all over the world. And the Google Cloud Platform is GCP, is a cloud computer resource provider. So it is a suite with various solutions. We won't be able to cover everything in offers because it provides number solution. I believe that to see everything, you would need the GCP certification, but here we will use it to work with functions as servers. And here, and here are the basic commands that we will use. I have left them here for you to consult later, okay? The libraries we will use. App Engine is responsible for creating application in the cloud. Cloud Build, which is the application builder. Artifacts, which is your container orchestration. Cloud Run is your functions as server or serverless. It is the one that will trigger the microservers. And OEM, which control permissions. And just to wrap up the vertical part about what Docker is. Docker are virtual containers where you can run operating system images, you can run Windows, you can run Linux, you can run Mac. I am using Linux. To compile Delphi for Linux, you can use the FAAS server. There are plenty of video on the internet about it, and here are the basic Docker's comment. Here, because we are going to use them. I left this one and this sudo docker build here marked because we will use it within the cloud. There won't be time to show it running in your local environment. So, as Linus say, talk ship, show me the code. Let's move on the practical part. So here in Delphi itself is nothing special. Here is my API gateway, which I built it. Let's just go back here. Here is my API gateway. So here it's just a horse. I'm listed on port 1818 with horse enable, where we have our routes. And here in the routes, I'm specifying the HTTP verbs and I will be used, which are get, post, put, delete, and path. And for each HTTP verbs, it triggers a REST request into my microservice. In this case, I have an address that the cloud provides me, but it's my link. And this here in API gateway so it will handle the routes of my microservices. And here is my deliver microservices, which is the same I created. It is also a horse, lesson on port 1818. If the same criterion, it has my link. Here are my HTTP verbs. It's a trigger to my Firebase, which is my database, right? So let's go to the cloud. Here cloud active all the services because it's take a long time. Just to create the cloud build, it's take an average of 10 minutes. So here within the cloud, you just create a new project since already to mine create here. I will be using my project, but there's nothing special about it. Just follow what is asked. Basically, next finish. And two active libraries I mentioned here, which are here. You just need to type their name, the app engine. Just type app engine here, and I will appear here. Here is the app engine. In the case that engine, when create, the only thing you need to pay attention to is to select the language you will use. There will be options, Python, JavaScript, PHP, or select others. You select others, and each every month will be flexible options. Flexible means we will be using containers, so just click on it and create it. Well, the same for the cloud build. Just type in the cloud build here because it will suggest it to you, and you just need to enable it. Just click enable and follow the same steps for all of them. You don't need to create any special configuration for it. Just for the app engine, you need this flexible language, and after you've activated all of them, come here and go into Google Shell. It will take a little while to start the machine, and I will open it in a sidebar here, so we have a dedicated tab for the console. Inside the console, I will specify my project, which is this project I created, this one that I specified here. And then inside here, we will click on this pencil icon to open the editor. By default, every time we create a project, Google already creates a default folder. So you just go to open folder, and here I create a folder called delivery, and I will open it. Here, my local files. I have the two compiled files from the file, which are my API gateway and my microservices, which are Linux binaries that I'm using via WSL, which is the Ubuntu I am running. I will need my app YAML and my cloud build YAML and the Docker file. So what we will do with this file, we will move them into the cloud. In this case, I created a folder called API Gateway and a delivery folder. And here you just drag and drop them into the browser. I have already saved some time, but by uploading them, let me live in here. And how this structure works, app YAML here indicates to our app engine that it is running in the flexible environment with containers, and it's running in custom because it will be a binary. In case it has Python, it would have Python with the Python compiler version. Your cloud build, I am pointing to the Docker service within the cloud, and remember that I left it here marked in the Docker. This sudo command docker build, this is the command we use to create Docker. So in this case, I am pointing to Google that in its argument I want Docker to do to build within my repository and the image I want it to create. In this one, I'm pointing to an image, and for it to create this image for me, it needs this file here, the Docker file. Inside the Docker file to use Docker. you will need an account here on Docker Hub. And here on Docker Hub, I am using this Ubuntu image. And inside Ubuntu, I am using version 22.004. So I'm telling my cloud that I want to get Ubuntu 22.04, which I will be pointing to this image. And here the runs are the steps that will be created. So I am telling it to create after it downloads that image. It will run and get updates to update the operation system and will install these libs. I am work with HTTP and I need SSL and curl here, so that two libraries are very important, and these are kind of Docker standards. I am asking it to create a folder called app with an mkdir. I am asking it to copy my API gateway, which in my binary, in the app folder. So I am talking it from outside and pass it into the containers it will create. Here I am using ch mode to give Linux permission. So I am execute ch mode here to give my binary permission, saying I will expose my containers on port 1818. Each is the port the horse is listening on, and here I am saying that my work there, each is for positioning, will be in my app folder. So when the container is launched, I will be in the app folder and I will run a cmd./API gateway to start the binary inside the Linux. And the same here, it's the same configuration for the other microservice in Docker file here. The only difference is that it in passing the binary of the microservice into the container. Here in the Google shell, we need to go into the folder here or cloud build. Let's type cd delivery and FAAS to see the directory. So cd API gateway. In case sensitive, FAAS to see the directory. Right. I'm in the folder with the binary and the configured files. So the app YAML is pointing to the app engine, and the cloud build will call the Docker file and start the build to create a repository. In my case here, I will go into artifacts, which is your orchestration. I have already created my folder with the repository, which is my Docker repo here. And to create this repository, it will be here. This command to create the repository with is gcloud artifacts repository, create a Docker repo, and just run this command here inside shell. Mine will give an error because it will say I already have this repository. When you run the first command in a folder, it requests authorization. You just need to click on authorization. It will run with your Google account. And here is the Docker repo, which I already created. It stores my container. I will have two containers in here. It just gave an error saying already exists. And to create this container, how it works, it this command here from a gcloud build summit. I will can the configurator and I will point to my cloud build, which is the cloud build from this folder here. So it will execute on this file here. Then you repeat the same process for my other microservices. So when you run it here, it will start the creation. The container is created here. What does it do? It will create an image. And in this image, you can control your version. Here I have the previous version, and here I have the last one I tested, which has 22 hours ago. Suppose I am upload a version and it has a bug and I need to revert to the provision version. I just need to point to provision container, which has the provisions versions of my binary, and you don't need to stop. You start at any moment. So if you have 10,000 clients using your microservice and it has a bug, you update and then it waits for all previous requests to finish the buggy service, and it moves all clients to the new version without noticing the update now. And after create the containers here, let's link the containers with our Cloud Run. Here, to create a Cloud Run, which is your FAAS, just create the service here, since I already have it. I won't create it from scratch, but I will show you how it works. To select the container that you just created in its version, it will go to the orchestration, explaining here, API gateway. It will pick the containers, and here is the last version I have, while the new version is being built, and you select the version. So you point to Cloud Run, so every time your Cloud Run is called, it will trigger this container. Select the number of instances and the type of authentication. I am using authentication directly in the API gateway. So if I open my API gateway, which I have already created here, it's running correctly here. It has already started running the steps I mentioned, which are the runs I created in the Docker file. And here, what happened when we implement? It gets a URL here, so I will work with this URL every time I call. This URL slash what is inside my Docker, which I define here in the file. In the case of my API gateway, it is listing on the URL of deliver MS order. So every time I call this URL here, it will trigger in this case one. Here one of the HTTP verbs that is running in the containers microservice, and let me see if it has already run. It has no run the status. So here I will edit the implementation. There is the option to configure the continuous deployment. Here you point to a Git repository, and every time you make a pull request, it updates for you. But we will not implement it here due to time constraints. Therefore, I will do it manually. Look, showing that my container support. So the Cloud Run needs. Look how cool. It updated my API gateway 1 minute ago. I will keep this new version and this here in the Angular frontend before updating the run. I have this class here where my verbs are, and it inherited from this class here, which is just in wait for the URL. So it will call my API gateway, and the API gateway will call the delivery microservice, and the delivery microservice will communicate with my Firebase. Every time I open this page here, it performs a get. So I will just separate it here and keep this one. So I selected here the new version of the container. Here it is, no, it is 2 minutes ago. And I will deploy it. Look how cool. It is deploying. The Cloud Run is updating. And I didn't lose access to the services. My get is working. And look here, it is working. My requests are 100% in the provision version from 22 hours ago, which is what is marked here. While the most recent version is still updating, I can even do a post here. I will put anything here, include post. Look at order tree here in Firebase. It continues work. And as soon as it finished, look, it updates now 100% of the requests are on the new version. This is the API gateway which is calling. The other Cloud Run and the process to update this Cloud Run is the same. So I just come here in Go shell, go back one folder level, cd to dot, orders, underline, deliver, ls, and I will execute this cloud build command on the cloud build of this delivery microservices while it is executing here. A good practice on the API gate should be exposed and not the microservice, and the microservice inside the orchestration should not be openly exposed. And here within Google itself, if I execute command, it will be a get. So if I call here I will call my container and Firebase request. Look, no access permission. All the API gateways call the microservice and just waiting to finish update the containers, the build finishing. Here are the steps of the Docker file, creating the target and it's finished. And here we will do the same as we did it for the API gateway. Look at the Cloud Run of the microservice. It goes to the registration and I will select here the last version that I created. And upon saving, I will implement here same thing and same microservice that is there. Use the Firebase directly, continues to function. If I change here its containers to work while it implements the new version, while our users are working using that revision versus into its update on the cloud. We also have reports. I can access metrics to make decision about the cloud, see how the requests are, see the request count of the containers, how many instances were needed to use, latency, a source of information about the usage, how metrics are available, because Google itself controls your infrastructure. Well, folks, that is, I will not go into many details here about the report. It's a very self-explanatory, and I hope I have managed to really simplify the cloud using Delphi because it's not a very common approach for Delphi people. We are more used to monoliths, but Delphi offers recourse for all its modernity. That is, folk. Thank you so much for watching.